Good morning everybody. Today actually I am going to start the electromagnetic part. Okay, and in previous class we have already studied that the vector calculus theory, divergent theory, green function, grid theory, and Stokes law. Okay, and gradient divergent current. And these are taking the concept of that part. We have to use this concept in deriving the wave equation and solution. What type of solution it is? Most of the net question comes from this part. One or two question comes from that part. I will complete that part as early as possible, so that you can study whole electromagnetic courses. So today I am going to start electromagnetic wave. Okay, this is based on, and I am going to give you, apart from traditional technique how to study that electromagnetic things, I want to teach you the in different ways so that you can easily understand the meaning of electromagnetic wave equation, Maxwell equation, only from the mathematical equation. Okay, no, don't waste so much time on reading line linguistic information that already mentioned in the book. Okay, today I am going to start wave equation. So before going to wave equation, you have to know what is a wave equation. And classical wave equation, classical wave equation we have already know df by dz square equal to 1 by d square f dt square. Okay, this is the second order differential equation with respect to spatial coordinate z, or you may take x, y, z, any function, and also the second order differential equation with respect to time. And here you see this is the v square. V square means you will get two solutions. Okay, one is positive v, one is negative v. The solution, I am not going to give you detailed solution of the differential equation. It is very easy. So I will discuss the what type of solution. This equation have three solutions. One solution is, suppose z1 equal to one solution. This is z1 z plus vt. Okay, this is one dimension. This solution means this is one of the solution of this equation. Okay, I think it is not visible. This is one of the solution. This solution means the electron wave traveling along minus z axis. Okay, and this another solution z minus vt. This means it is along positive z direction. Okay, another solution. Suppose z1 z plus vt and z2 z minus vt. This is a complete general solution. Okay, the combination of two parts. What does it mean? This plus z, it is negative z axis, and z minus vt, it is positive z solution. This is also solution. This is also solution. This may be also solution. Three possible solution. Okay, this is, you can imagine. Suppose this is a candle. This is a bulb. Okay, bulb. This is a bulb. Electrical bulb. Electromagnetic. This is suppose z axis. Electromagnetic wave propagating along positive z axis. Okay, that is represented by G2. This is represented by G2. Okay, and suppose electromagnetic wave propagating along this axis, then it is represented by this part, G1. And now we are considering electromagnetic wave to the left, to the right. Then you have to represent this part. Okay, this is the general solution of wave equation. So what we understand, this differential equation, second order differential equation, this is a v square. V square means it will have two solutions. One is positive z direction, one is negative z direction, and both solutions, positive propagation of positive side and negative side, we can combine and represent by this linear solution. Okay, this is also solution. One thing you remember, whenever we take the solution, suppose cos z plus vt. This is the solution of this equation. Okay, one thing you have to ensure, there must be z and t. Suppose if I write data cos vt, this is not the solution of wave equation because time is there, but z is not there. That is why this is not the solution of wave equation. Okay, clear? This is a general thing. Now I am going to start the Maxwell equation. Maxwell equation. What does it mean? Maxwell equation 1 is Maxwell equation 1, divergence of E equal to rho by epsilon. Okay. 2, divergence of B equal to 0. 3, del cross E equal to minus del B by del T. 4, del cross B equal to mu J plus mu del D by del T. Okay. First see, this equation derived from Gauss law, the differential form of Gauss law. Okay. This equation, and this is magnetostatic equation. Divergence of B is 0. I have already told you what we mean by divergence. Divergence means outward flux or inward flux. Okay. So divergence of B is 0 means there is no outward flux, no inward flux. Because whenever we consider a conducting wire, magnetic lines of force will be circular. Suppose this is a conducting wire having current I. So magnetic lines of force will be circular and having center on the axis of conductor. There is no possibility of outward flux, inward flux. That is why it is 0. And another meaning of this equation is divergence of B is 0 means there is no monopole, magnetic monopole exists. But similarly here, if we see divergence of B is not 0, that means there is a positive outward flux. It may be negative. Okay. It may, if the source is positive, suppose this is positive charge, then it will be outward flux. Then divergence of E equal positive. Suppose it is negative charge, then it is flux is inward, then it will be negative. Okay. That this is not 0, that means electric monopole exists. That's we know. Electron, we can get electron, we can get positron. Okay, positive charge particle. So this is the meaning. Third equation is that curl of E equal to 0. I have already told what do you mean by curl. Curl means rotation. Okay, curl of magnetic electric field is what we say. This equation is derived from Faraday experiment. Okay, this equation means time variation, special variation of electric field produces time variation of magnetic field or vice versa. Okay, and fourth equation, originally this is equation MPS law mu J. From where it is derived, we know the B dot dl equal mu I. Is it okay? So, and this is according to Stokes law. I have already told. What do you mean by Stokes law? Stokes law. This is a Stokes law. Stokes law. B dot dl. When there is a line integral, we can take it a surface integral of that vector. Okay. This is the Stokes law. Line integral we can convert to surface integral, and Gauss divergence law, but divergence of any function we can convert it to surface integral. Okay. This is the Stokes law, and divergence law is this one. Divergence of V dV equal to V dot ds. This is Gauss divergence law. This is Stokes law. Line. This is a dot dl line integral. We can convert to line integral. So you can convert V del cross B dl del cross B ds equal to I is the total current. So what is the total current? Current density into area. So I can convert J dot ds. So ds cancel. So del cross B equal to mu J. Is it okay? This is the differential form of MPS theory. Originally MPS equation is this one, and this is differential form of MPS theory. Clear? Second equation is that the original equation is this one. Okay, original equation is this one. Why they have, and this term they have modified later. This is called displacement current density. Why they have modified? I just want to give you hints. Why they have modified this equation like this? Mu J plus one additional term is added here, and this equation is also known as the Maxwell equation. This is the modified MPS theorem. Okay, modified differential form of Ampere law. Okay, why they have modified? See, divergence of B equal to mu J. Clear? Now, if I take the divergence of curl of any function, is I can take mu dollar J. Is it clear? I take the divergence both sides. Okay. Now what happened? We, as per vector rule, divergence of curl of any function is always zero. This is the rule of vector. divergence of curl of any function is always 0. That means left hand side is 0. But what about right hand side? Mu divergence of j. So we know the continuity equation, divergence of j equal to minus 0 by dt. Is it okay? This is a continuity equation in electromagnetic theory. I will teach you in the later. But that is why I am giving you the brief idea about the history, why they have developed this equation. So divergence of j equal to what? You can replace 0 mu minus mu del rho by del z. What do you mean that left hand side is 0, right hand side is not 0? This is contradictory to the mathematics. Okay, that means this equation, when charge density is rho is the charge density in the conductor. If the charge density in a conductor is a constant or uniform, then d rho by dt is 0. Then this equation is valid. Then if charge density in a conductor is constant, then left hand side is 0, right hand side is also 0. If it is rho is constant, then this is 0, then divergence of j is 0, then it is satisfied. But if the charge density in a conductor is not constant, it is variable, then this is not 0. Then it is not matched with the mathematical rule. This is a contradictory to mathematics. That is why to satisfy this, that means this equation is partially, this equation is valid under certain condition. Okay, but it is as a general, this equation is not valid to satisfy this mathematical contradictory statement. So they have added another term. They have another term, that is mu zd. So now, okay, zd is derived from here. Rho means what? Zd derived from here. You see, divergence of zd, divergence of j equal to minus 0 by dt. And first law, rho equal to what? Divergence of E epsilon. Is it clear? dt. Then j equal to how much? Divergence cancel out. Minus epsilon naught dE by dt. And this is called displacement current. Okay, clear? Displacement current is derived from this equation. Okay, this term is a displacement current. This term plays significant role in deriving the wave equation. If this term is not there, then there is no possibility of deriving the wave equation. Remember, displacement current played a significant role in deriving the wave equation only. Okay, otherwise we never derive the wave equation. Okay, this displacement current we always remember. Now I am writing again, divergence of j equal to, this is from continuity equation. Okay, this is from continuity equation. Divergence of j equal to minus rho means divergence of E epsilon naught. This is from Maxwell equation. Okay, first term, this equation dt. So I can take it divergence of j equal to minus divergence of E epsilon naught dt. So divergence cancel. So j equal to minus epsilon naught del E by del t. This is del E by del t. Okay. And this is known as a displacement current. And if this term is added here, then now if you say that take the divergence both sides of this equation, left hand side is always 0, right hand side is always 0. What that means, this mathematically contradictory has been removed. Okay, that is why they have theoretically added this displacement term, and this is known as a displacement current. Later they have experimentally verified. Okay, and this, remember, I am telling you another thing. Zd, now Zd, remember one thing, Zd equal to epsilon naught del E by del t. Okay, this displacement current is valid for time alternating current. If it is DC current, it is independent of time. So then E is constant. There is no displacement current. For battery, you never get displacement current. Okay, displacement current, it is for time variation of current, alternative current, AC current. Okay. Now this is the Maxwell equation. Already this is the meaning of Maxwell equation. Okay. In free space, what happens? If it is free space Maxwell equation, wave equation, I am going to derive the wave equation in free space. Now wave equation in free space. Wave equation in free space. Free space, what happens? Rho is 0. So J is 0. This is the condition. Why rho is what? Rho is a total enclosed charge as per Gauss law. It's a in free medium. Free medium means wave equation in free space. Suppose vacuum, then rho is 0. Free charge is 0. Then current is obviously 0 because current is equal to rho V. Rho such density in velocity. So V it is 0. So Maxwell equation I can modify 0 to divergence of B is 0. Del cross E equal to minus dB by dt and 4 del cross B equal to mu, J is not there, so mu epsilon del E by del T. Now it is I am talking about free space, that's why I put epsilon not mu. Clear? So another meaning of this equation telling that don't think that divergence of E is 0 means there is electric field is also 0. Although there is no charge, but the electric field does go 0. Okay? Clear? Now taking the curl of, you know the cross, I assume that you have already know that factor equal product. Okay? I am taking the curl of any equation, any two equation. Then what happen? Take the curl of T equation number T. Then what happen? What will you get? Del cross E, del cross E, left side of this equation equal to minus del cross del B. Oh, clear? So this equation means as per factor triple product. Well, factor triple product, you check it in David Griffiths books. If you don't know factor triple product, you have to know this is factor triple product, factor scalar product of factor. And this is already available in David Griffiths book, chapter number 1, around page number 25 to 26. Okay? Then you can take it, this d by dt, it will come inside del cross B. Clear? Okay? Now, as per rule, this is 0. This is first term is 0. Second term, I will write del cos E equal to this minus cancel. I will put directly. And del cross B equal to this one, I can put directly, so mu naught epsilon naught del square E by dt square. Okay, so what I am getting the wave equation in free space, I am removing this part. What I am getting the wave equation, this del square E equal to mu naught epsilon naught del square E by del T square. I am taking the equation number T. If we take the equation number 4, take the curl in the both side of equation number 4, you will get another wave equation del square B. You will get the same equation, only replacement of E by B. Okay, same equation you will get. I am taking the curl of equation number T. If you take curl of equation number B, then you will get this one. Okay. Now you think that this is the Z wave equation. Now this is I am writing here so that it will be easy. Mu naught epsilon naught del square B del T square. This is the wave equation in free space. Okay. Now I have already told in the initial time that is what is the Zenel equation, Zenel classical wave equation. This is the classical wave equation, right? Classical wave equation. If we compare, this is suppose A1, this is suppose A2. If we compare A1, compare A1 and A2, then what I will get? Okay, what I will get? F means function. It may be electric field, it may be magnetic field, whatever it is. So forget about that function. Function is stand for E as well as B. Okay, what I am getting is B square. 1 by B square means what I am getting? Mu naught epsilon naught I am getting. Okay, this equal to V equal to how much? 1 by mu naught epsilon naught. It is represented as a velocity of c. Why? If we put this value, mu naught is equal to 4 pi into 10 power something, and epsilon is equal to 8.85 into 10 power minus 12. If we put this value, I am not going to do calculation. You will get this value 2.9979 into 10 to the power 8 meter per second. Okay, it is approximately 3 into 10 to the power 8 meter per second. Okay, this is called the velocity of electromagnetic wave. Okay, and you have seen this displacement current term only played a significant role. Okay, how? I have already shown you. Okay, when I take the curl of, this is curl of C, curl, this is the Maxwell equation, dEt dV. I take the curl of both equation, both sides, curl of B, it will be, so del is a depend on xyz, so it will come inside this bracket, that is why. Okay, this equation, the divergence of E minus del square E equal to, this part is derived from del square B equal to mu j is 0, so mu del E by del T. If we put this value, so mu del D by del T. Clear? So this term is 0. This is equal to minus is plus. See, right hand side. This right hand side of wave equation is derived from the displacement current. This is the displacement current term. Or if the displacement current is not there, then you cannot derive the wave equation. This displacement current term, if it is 0, then divergence of del square E is 0, no wave equation. Okay, only this is the displacement part played a significant role. Okay, clear? Now I modify the equation, simply modify the equation like this. Okay, del square E equal to 1 by c square del square E by del D square. Okay, del square B equal to 1 by c square del square F by E by D square. This is the wave equation. Now question is that what is the solution of wave equation? Solution of wave equation. Okay. Solution, there is a three possible solution. You can take in terms of Phasor Form. You take this solution of the wave equation. Solution of the wave equation, E equal to, if you take this differential equation, E naught is a vector, is a complex number. It may be real number, it may be complex number, whatever it is. E to the power I k dot r minus omega t. Okay. K dot r means k wave vector, r is x plus y plus z, t component, and you can express it either cos or sin. You can take as a E naught cos k dot r minus omega t. Clear? You can take sin also, no problem. Cos is also solution, sin is also solution. You can express in the Phasor form. Okay. Similarly, B equal to D naught e to the power I k dot r minus omega t, or you can represent again P naught. I am writing here sin, or you can take it a cos also, no problem. Kr minus omega t. This is the solution. This type of always solution of the wave equation is like that. Okay. Now this is the solution I am telling you. So verification of wave equation, whether this solution satisfy the Maxwell equation or not. So I am giving you short tricks. You see, if I take the solution, Maxwell equation I am telling you, Maxwell equation I am telling, going back. Okay, Maxwell equation. One is a divergence of E equal to 0 in free space. Divergence of D is equal to 0. Then del cross E equal to minus del V by del T, and for del cross B equal to, and mu naught del D by del T, or mu naught epsilon naught del D by del T. This is the Maxwell equation. Okay, what I am doing here, if we take the divergence of E is equal to, I have already told you E equal to E naught e to the power I k dot r minus omega. Or if it is one dimensional, it will be k dot r x, k dot y, k dot z, whatever it is you like. So it will have, if we take the differences, so what will have, you can ensure ik into E, you can check it. It's just differences of k dot r, ik will come out, it will exponential part remain same. So that means divergence equal to ik, short form. Because why I am giving you this? An important point. So always, because in exam we don't have time to take the differentiation and do the curve. We don't have time. So solution is always like that, or it may be it is a Phasor form, or it may be in cos, it may be in sine, whatever it is. So del equal to, you always replace ik. Okay. Similarly, if you take the curve of this equation, then what happen? You will get del cross equal to ik cross. This is a formula, short term I am giving you. I will verify you. And del t equal to minus I omega. One thing, why minus I omega? If we take del E by del t, then what happens? Del E by del t, if we take the differentiation, I omega will come out. It will be minus, because minus omega t is the second term, that is why minus is there. So in some equation, omega t is the first term, k r is the second term. Then this is minus ik. So one thing is, remember, when ik del is equal, if you write ik, then del t equal to plus minus I omega. If it is minus, then it will be plus. Only two terms you have to remember. So we will verify how, whether this is correct or wrong. In electromagnetic field, electric field, we know electric field, magnetic field is there, and propagation direction, T vector. Okay, T vectors are mutually perpendicular to each other. So that things we can verify. Suppose K perpendicular to E, perpendicular to B. How can you verify? You check it. Simple way, divergence of E is 0. Okay, that means I am shortly put del equal to ik equal to 0. That means for I is 0, k dot E is 0. Is it okay? K dot E is 0 means k vector is perpendicular to E vector, because A dot B equal to AB is cos theta. So cos 90. So that means k is perpendicular to E. Correct? Similarly, if you take the equation number 2, divergence of B equal to 0, that means ik dot B is 0, and that means k is perpendicular to B. Clear? That means k is perpendicular to E, perpendicular to B. Clear? This is the concept you have to gain. Otherwise, what happen in net gate exam, if you see the question paper, understanding of question is very difficult. Once you understand, you see the answer is very short, and all the hints of answer is already given in the question. So you have to understand anyhow the question very efficient manner. Okay. This is the first and second law. I can ensure that using this equation we can verify that propagation direction, electric field direction, magnetic field direction, all are mutually perpendicular. Similarly, if we take the third equation E equal to minus dV by dt. Okay, short tricks I am putting. When you take the curve, always remember we have to take determinant. If we take the determinant in calculation, there is a possibility of minus plus error. So in order to avoid calculation, I give you short terms. Just put del equal to ik into E equal to, then I have already given del t equal to I omega minus. Clear? So minus plus I omega B. Is it okay? So I cancel k dot cross E equal to omega B. Now you tell me, what is the meaning of this equation? What is the meaning of according to vector? Now back to the vector. See, if A cross B equal to C, what do you mean by this equation? So always remember, cross product of two vector always give a area, any vector. Okay, this vector is equal to the C which is C is known as the area vector. This area vector is normally in vector calculus we write like this: A cross B equal to C n cap. Okay, this n cap means unit vector. The direction of C vector, C is known as the area vector, which is perpendicular to A as well as B. So it is like that. Suppose this is A vector, this is B vector, then cross product it will create a plane in this one. This is A cross B plane is equal to C plane. C plane is like that. This will be like this. Okay, that means this C vector is perpendicular to A as well as B. Here you see, this is for particular electromagnetic wave, frequency is constant. So this omega is constant. So you don't have to consider omega is equal to 1. Then K cos E equal to B. What do you mean? Then K vector E vector create a plane, so which is area vector, and nomenclature as a B. This B vector is perpendicular to K as well as E. That means what? That means K is perpendicular to E as well as B. Correct? Is it okay? Now, this is the meaning of vector. Now, you see, in most of the in physics, there is a lot of mathematical formula. We cannot afford. That means I am telling you that we cannot remember all this formula. So I am giving you a short trick. Within 2-3 seconds, you can derive. Because this is a thought thing, you can easily remember this equation, Maxwell equation. Put this value. This is omega. This is relation. Now you see, K cos E equal to omega B. Okay, kill it. Then I have already told the K is perpendicular to E as well as perpendicular to B. So A cross B equal to how much? AB sin theta. So it is 90. I can put directly in magnitude form. Now it is vector form. Now I put magnitude form. Okay, omega B. But one thing is, remember, suppose if you want to find out the magnetic field direction, then K direction unit vector, E direction prospective cross product you will find. So K equal to twice pi by lambda, we already know wave vector E, and omega equal to twice pi nu B. So if you B is equal to E by C, this is the relation between electric field and magnetic field. Okay, these relations tell that magnetic field exists in the electromagnetic wave. Magnitude of magnetic field is C times smaller than electric field. Okay, C times smaller than electric field. It is very negligible as compared to electric field. Then why it is so important? Why it is so important is that why it is important. Whenever we talk about, you have already known, whenever we talk about polarization of electromagnetic wave, we always talk about polarization of electric field. Why not we never talk about polarization of magnetic field? This you can check in the book. Chapter number 9 also, chapter number 10 also. If you check chapter number 10 and chapter number 9 and figure number 10 point something, 10.1 or 2, 3 in David Griffiths electromagnetic book, they have clearly mentioned polarization of electromagnetic wave conventionally is present polarization of electric field. Why? Because of this. Okay, B is C times smaller than E. But energy of electromagnetic wave is equally shared by electric field as well as magnetic field. Clear? Now, back to this point. Now is that we have to. Now we have to learn. Have you remembered this equation? So when we talk about polarization, polarization of electromagnetic wave, A square plus this is D square minus twice AB, sorry, not twice AB, EX, EA, EY, D cos delta equal to sine square delta. Have you remembered this equation? This is a polarization equation we will study in the next class, because polarization of electromagnetic wave is very important for exam purpose, net exam, whether it is circular polarized, linear polarized, elliptically polarized, left circular, right circular. That thing we will discuss in the later. But this is the equation of polarization equation. Okay, we will discuss it later. Polarization, now you remember, polarization of electromagnetic wave is always talk about polarization of electric field, non-magnetic field. Clear? So direction of vector, how we can remember? You see this is in here. I'm going to fourth cycle. This is unit vector I, j, k. Is it okay? This is a rectangular coordinate system. This is in spherical cone r, theta, cap is there, phi cap. Okay, and we normally write this is unit vector. We normally write as a ar, a theta, a phi. These are the three unit vector in spherical coordinates. ar means r cap, a theta means theta cap. Okay, same. Similarly in r, ar, a phi is it. This is in cylindrical coordinates. Now in electromagnetic, I have already told electric field, magnetic field, and propagation direction all are mutually perpendicular to each other. So E unit vector, D unit vector, K unit vector is clockwise direction. Okay, why it is very important? So I cross j equal to what? K. K cross j means minus I. Similarly here, E cross B equal to K. K cross B equal to minus I. And this is very important in for exam purpose to remember, because this is not given in a book. Because in exam what happens, they will give you electric field and you have to find out the magnetic field. Then main focus is that I'm telling you, just remember this. It is like XYZ, all are mutually perpendicular. Rectangular system, spherical system, cylindrical system, and electromagnetic wave. Okay, and K as well as Poynting vector. I will tell you what Poynting vector means. Okay. Now question is that in exam, for example, now we come to the question. Okay. If a monochromatic EM wave propagated along z-axis, okay, its electric field is given as E equal to E naught E ZT equal to E naught e to the power cos kz minus omega t plus delta equal to x. Do not confuse. This is Z means electromagnetic wave propagating along Z direction. Okay, this Z means this is not direction of electric field. Remember. And another important thing, when you talk about propagation of electromagnetic wave Z axis, then wave vector which is defined the propagation direction is associated with the Z. If it is K is associated with X, then electromagnetic wave propagating along X axis. If it is associated with Y, then it will be Y axis, something like that. So what is the direction of electric field? Now question is that magnetic field I have to find out in exam. Exam what happen? They will give a electric field, they will receive the magnetic field, or sometimes they will give a magnetic field. You have to calculate the electric field. So what is a magnetic field? How can you calculate? See, this is B naught. This part will remain same. No need to do anything. Okay. This is cos kz minus omega t plus del. It will remain same. This is a harmonic term. It will not change. Only we have to verify the direction. So in exam, this is a 3-mark question. No need to do anything with this thing. Only check the direction. So quickly see what is the direction of electric field. The electric field of direction, which direction? X cap. X cap means I cap. Is it okay? And this is propagation direction vector. Propagation vector is Z cap. Z cap means K cap. Is it okay? Now we draw the circle E, D, K. Now what we need? Unit vector of B need. Okay. Then K into E, clockwise direction. B equal to unit vector equal to K cap into E cap. K cap into E cap equal to what? How much? K cap into I cap equal to J cap equal to Y cap. Is it okay? So it just represents this is Y cap. And B equal to, I have already shown you, then B equal to how much? E naught by C. This is the answer. It's just simple, nothing to do. Just set that direction. Okay. Suppose you want to verify your answer is correct or wrong. Correct or wrong. You can again say, this is a question. Suppose magnetic field is given. Okay. Then, what will you do? And then electric field you have to find out. So it is E naught by C. So yeah, and electric field is C times less than magnetic field. So it will be how much? E naught. This cos part will remain same. Kz minus omega t plus delta kilo. Then it is along y-axis, it is z-axis. So this is, remember a cycle E, B, K. This is unit vector. Okay. E, B, K. Then what happened? And we need the E. E means B cos K. B cap into E equal to B cos K equal to E. Is it okay? B cos A. So B direction is y cap minus K cap equal to how much? I. Is it okay? X. I am getting the answer again, back calculation. That means your answer is correct. Okay. Now I am giving a confusion. I am not giving this way. I am doubting this way. Changing the direction. Cos omega t minus kz plus delta, suppose. Minus delta. So what is the direction here? So you have to very careful. Now what is the standard equation? Standard equation is that E equal to E naught into kz k dot r, k dot, okay, dot product of k vector. K means it is three-dimensional vector, kx, ky, kz. R is also three-dimensional. It is, but we are considering wave equation one-dimensional, so that is why we are writing z only. It may be three-dimensional. Minus omega t. This is the standard equation. We can express real term also, cos E naught cos k dot r minus omega. So k dot r is the first term. Okay, omega t is the second term, but here k is second term. Okay, that means what? You have to transform this equation. This equation you have to transform like this. E naught, because cos is a even function. Okay, cos minus of x equal to cos x. So in that case, cos kz minus omega t plus delta z. Is it okay? It will not change the direction. Why not changing that? I take minus cos of minus x equal to cos x. So they will not change the minus. So direction of electric field along the same direction. It will not change the direction. But next question I will see. Again I am changing this one. E naught sine. Then what happens? You see. In that case, if it is, you say kz is the first term or second term, you say it. Then what happens if I write this is x cap, suppose x cap. Then you have to transform in E naught sine kz minus omega t plus delta. Why I am doing this? Now this question, electric field, direction of electric field is electric field direction unit vector. Which direction? Do not write x cap because minus is already there. It will be minus x cap. Okay. Then k direction is z cap. So what is the direction of electric field or magnetic field? E D K. Okay. Then I need the B unit vector equal to k cap into E cap. K cap means what? K cap is there. E cap means electric field direction minus of x cap equal to k z into I into y minus y cap. Okay. So magnetic field will be B equal to E naught by C. This term will remain same. This is the sign term. This will remain same. This is equal to minus 1. This is the correct answer. You have to do this way. Okay. But in complex form, Now, different equation I tell you. So if I tell you E equal to into W E naught e to the power I and kx x plus ky y minus omega t and z. Now what do we understand? So in previous one question in xy plane. Now what happened? Now you cannot say the electromagnetic propagation is along x direction as well as y direction. Okay. Now it is a two-dimensional case. How can you find out the direction? Suppose magnetic field, this E naught by C, it will remain same. Okay. This part will remain as it is. No need to change anything. It will remain same. Only you have to set the direction. Direction you have to find out. Direction is necessary. So in exam, no need to do anything. You set the direction. Okay. Now what is the direction of K? Now it is, what is the direction of K? Can you tell me? So in this case, you can transform like this, right? E equal to E naught e to the power I K dot R. Initial standard equation is K dot R minus omega t. It is Z, right? Is it standard equation? Now if I write equal to E naught e to the power I kx I cap plus ky y cap dot x I cap plus y z cap. Is it okay? Minus omega t. If we take the dot product, this term, you will get this one. That means in short form, if it is like that, we always remember unit vector of k. K is kx. This is associated with x. So you write I cap. Ky. It is ky associated with y cap. So y cap or z cap. So what is the direction of? What is the direction of now according to this rule? E, D, K. Now electric field is given. This is already propagation K direction we know. We have to find out B. So B direction, B equal to B unit vector equal to K into E. Okay. K into means this is KXI, KY, J into unit vector Z. Z means K cap. Now be careful in when you take the cross product of two vectors, always you have to find out the determinant form. Okay? I, J, K, okay? Kx, Ky, 0 and this is 0, 0, K. Now if you take the determinant, so this I, this is K, this will cross product. For simple K, this is unit vector. This is not propagation wave vector. This is K vector. K means if you confuse, you write the Z cap. Okay. Now you take the I into Z. What will happen according to this one? This is 1. Okay. This is 1. You take. You just do it. Just do it. This is I. This is 1. This is 0. This is 1. You can find out whatever you are getting. Suppose you get something M direction. I am not doing the calculation. This is simple calculation. Okay. This is suppose this is the cross product. This is the indeterminate form. You do the calculation. This is the basic calculation. So suppose I am getting M cap. Okay. M cap I am getting here. So then in that case, what is the magnetic field? Magnetic field do not change. You see this part will remain same, and this M cap will you have to put here. So in the exam you have to find out the direction only, nothing else. Okay. Suppose if I give you another question is that in exam in the last time I have given you one or two questions. Then this question comes in the net exam. So I will give the question. This question comes in the net exam. a plane polarized free wave and a plane polarized wave xz is equal to at t equal to 0 at a plane polarized wave at t equal to 0. Okay, at t equal to 0, t equal to 0 means omega term will 0. Okay, is given as kz e to the power I 6x plus 8z. Is it clear? And now question is that what is the wave vector? What is the magnitude of wave vector? Okay, magnitude of wave vector, and what is the magnetic field? So if I take, suppose if it is x, z, t, if I write in times, omega t will be there. You can represent j e to the power I 6x plus 8z minus omega t. Now I am not considering time. So what is the direction of electric field? This is j. So direction of electric field, when you take, if you want to find out, suppose if you want to find out, this is 10 by c, right? 10 by c. This term will remain same. This term, no need to change this term, this part. Only I have to find out the direction. Okay. Direction is what? Now you see 6x z. This is as z means as per standard equation k dot r, kx x, ky y, kz k. Those kx equal to how much? Kx equal. What is the unit vector of k? C. Easily you can find out. And 6k, 6 I cap, right? I cap 6x. Why I cap? Because 6 is associated with x, so it will be 6i plus 8k, right? Then according to this rule, what? E cap, B cap, K cap. Okay. E cap, B cap, K cap. Then we need to find out B. So B cap equal to K cap into E cap. What is the K is this one, 8i plus 6k into j cap. You take the product. The direction easily, you just put the direction, nothing else, nothing to do with direction. Only find out the direction. This is one way. Or another way, if you want to do another way, you see this way, because this is a Maxwell equation. Okay, I have already told you Maxwell equation. Del equal to ik into E. Then this is minus r omega b, short form I cancel. This is all, it will be absent. So omega b. Is it okay? So b equal to what? B equal to 1 by omega k into E. Okay, this is not unit vector. K vector. This is not the unit vector. Okay, E is given. Okay, now you see this k vector equal to what? K into unit vector. K cap. Is it okay? K vector is k into, this is a magnitude form, into unit vector. So I can take it like this: k e omega, this k cap minus e cap. This is unit vector. So k cap is, and in example I have given you e zt zx equal to 10j e to the power I 6x plus 8j. This is given. So k cap means what? K cap means this is 6i plus 8 z. This is z, k cap. Okay. K means, if you confuse, you can write z cap also, no problem. And E direction of E is z cap. You put this value and take the cross product, which is the answer. And rest of the things will remain same. Okay. And this question is a 5-mark question. You can easily find out. Okay. I think I will give you more question after finishing this part. Again, I will discuss the net question. For all possible question, I will discuss once after finishing this part. These two, 3 example I am giving you only to understand the solution of electromagnetic wave. Okay. Now we see. Now energy associated with the electromagnetic wave. Energy EB in EM wave. EM wave. I have already told you in electromagnetic wave, the total energy is shared, equally shared by electric field and magnetic field. Now my question is that what? How much energy is shared by electric field? How much energy is shared by magnetic field? So I will calculate here. Have you remembered this formula? Energy. Have you remembered this formula in electrostatic? E dot d d. Why this is integration? This will integrate by the whole volume, because we are talking about electromagnetic wave in free space. So the free space volume, total volume in the free space. Free space. E dot d, electric field displacement vector. D equal to how much? We know already. Half E dot epsilon naught E, okay, dV. A dot A means what? A dot A means A square. So epsilon naught is come out. So it will have epsilon naught E square V. V means total volume. Now if I write this is energy density, that means U by V equal to UE by V equal to half epsilon naught E square. Okay, this is energy density. Okay. Now, what is the energy? Because I have considered E equal to E naught e to the power I k dot r minus omega t, or you can, it is three-dimensional electromagnetic wave. If it is one-dimensional, I can write I k dot kz, okay, minus omega t, this one. Or you can express E equal to E naught cos kz minus omega t, or you can take sine also, no problem. E naught sine kz minus omega t. You see, if you take this one, your answer will remain same. If you take this cos part, you will get the same answer. If you take sine, you will get the same answer. No problem. This is the Phasor form. What is a Phasor? Phasor is a mathematical entity to simplify the mathematical calculation. It's nothing else. But whenever we do the calculation, we have to take the real part of the Phasor form. Suppose e to the power ix. Okay, e to the power x cos x plus I sin x, right? So whenever we measure the physical parameters mean energy, momentum, entropy, whatever it is, then we have to take cos or sine part, avoiding imaginary concept. Okay? If it is imaginary, then there is no meaning of physical quantity. Physical quantity means quantity we can measure in laboratory. So that is why we can take sine, we can take cos. Only there will be a phase difference between sine and cos. Okay. So energy associated with this equal to, according to this, suppose I am taking cos. Okay, you can take sine also, no problem. Answer will remain same. It will happen 1 by 2 epsilon naught E naught square cos square kz minus omega t. Correct? Okay. And now to avoid confusion, if I take kz minus omega t plus delta plus something plus blah 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 like that, there will not change any energy. Okay. This constant term, this actually not constant, this inside bracket term, any term you can add, but provided there must be z, there must be time. Okay. This term will not affect. So this is called instantaneous energy in electromagnetic wave. What is the RMS value? Average energy. Average energy. Number one, average E. Average energy E. This question comes in the late exam. So in an exam, what happens? They will give a electric field and they will ask to find out what is the energy, electric field energy in electromagnetic wave. Average energy means this is constant E naught square. This I have in the last class I have shown you the constant you cannot take the average. Okay. Then cos square. This middle bracket term I am not writing because this term will not affect the answer. And for save time I am not writing here. So what is the average value of cos theta? Cos square. It's a short term notation because you know cos square plus sine square x equal to 1. Okay. So what do you mean by if you take the average of cos or sine, you must have get half. Okay, so this will cos square value average will be half over a complete cycle. Okay, but if it is epsilon of E naught square is half, it will be equal 1 by 4 epsilon naught E naught square. This is the average energy in electromagnetic waves. Okay, or if you confuse average value, we can get measure. This is the equation. Okay, we have already studied in the high secondary. So dt at dt, right? 0 to 3. This is the formula. You can check it. You will get that. But average of cos, this is 0. Average of sine is also 0. Why 0? I have already told you. Because this is suppose sine. This is a complete cycle. Average equal positive, average equal negative. Plus 5, minus 5 equal be 0. So average of sine something is always 0. Okay, why? Plus half, minus half. Plus 5, minus 5 is 0. Average value of cos sine is 0, but square is half. You can say using this formula, so no problem. But short term is cos square plus sine square is equal to 1. So cos square average must be half, sine square average must be half. Okay. This is energy associated with this one. Now, if it is now magnetic energy 1 by 2 B dot H dV. Okay, H means what? B, A magnetic field, and H means always we numerical say the intensity. Okay, B is equal to B by mu. Is it? Okay, then I will get 1 by twice mu naught B square V. Clear? Similar to the previous equation. So energy density, magnetic energy density 1 by 2 mu naught B square. And if we take B equal to this one, B equal to B naught cos kz minus square. Or you can take sine also, no problem. You can take sine. So B naught square, sine square, this one. Okay, this is will give you half. So 1 by 4 epsilon mu naught B naught square. B naught square means how much? E naught square by C square is equal to mu E second average value of energy. This is instantaneous energy, this is average energy. Okay, that means energy, electromagnetic energy is equally shared by electric field as a magnetic field. Okay, in exam, suppose this energy we are taking like this. We are taking this solution is like this, right? E naught cos kz minus omega t plus suppose that this solution whatever I have derived taking this type of solution. If I take this solution in exam, that equation I have seen in the net exam, E naught e to the power minus delta z cos kz minus omega t plus delta. So what happened in this case? It's nothing. This I have already UE calculated 1 by 4 epsilon naught E naught square, and which is equal to mu m. Is it okay? Now what happened in this case? Because mu E equal to half epsilon naught E naught square e to the power twice delta z, and this is cos square this time. Okay. Now when I take a average of mu E average, then this whole term is a constant term. Why it is constant? Because we are going to take the average time average, but this term does not contain time, so you can consider the constant. So it will have, this part will give half, so it will be 1 by 4 epsilon naught E naught square e to the power minus twice delta z. Clear? So this will consider the constant. You can check the net question paper. You will find this type of question. Okay, I think you understood. If you have any query, you can send us a message. Okay, I have a soft copy. This is for especially for net gate, and if you really necessary, I can send to you. That soft copy is prepared by me and totally based on exam. And I have mentioned all the possible question, that because here there is a time limitation and space limitation in mobile phone. So because of which most of the things I have skipped. Okay, I hope you understood. And last point I am going to give you, after that I will going to all this one or two calculation I am giving you, because at the end I will discuss a lot of question only for what type of possible question. But this one or two numerical problem I am giving here only to make you understand to electric field, magnetic field, contribution and RMS value, that's why. Okay, last one time is I am giving you, so I am not going to detail of that part. Poynting vector. Poynting vector. What is a Poynting vector? Is represented by 1 by mu E cross B. Okay. What does it mean? So initially I draw a diagram where I mention E cap, B cap, K cap, or also S cap. Why? Because you see, this is a Poynting vector, is a area vector, correct? Why it is called area vector? Because this is a cross product of two vectors. You will give area vector, correct? And this vector direction of this area vector S is perpendicular to E as well as B. E, B, K, S. Okay, clear? And this Poynting vector measure the flux of electromagnetic radiation. Measure the flux. So this is the power energy flux per unit area per unit time. Okay. The power is formula, that means total power of electromagnetic radiation integration, okay, is represented like this. P limit r tends to infinity, integration surface closed part. This is closed integration because whole space is considered as sphere volume. So S dot ds. Okay. I want to highlight one point. After that I just finish this one. So I will give the calculation how Poynting vector is calculated for different form of electric and magnetic. Yeah, I will discuss in the next class. So this means that if we write 1 by mu limit r tends to infinity and E cross B dot ds. ds means, you know, this is the volume in 3 dimensions p, r square sin theta d theta d. Okay, not dr. Now you see, if I simplify 1 by mu naught, limit r tends to infinity, E cross B, this dot, this r square sin theta d theta d, right? This is the volume in 3 dimensional space. Now you tell me. Now I am going to tell you one important things. The why static charge never radiated, why moving charge, only accelerating charge radiated or decelerating, always remember. That hydrogen atom in Bohr's theory in hydrogen atom, we always consider whenever electron moving in a stationary part at uniform velocity, in neither absorb energy nor radiate energy. Why? See, why I am telling you here. In static case, so far we have studied in static field. Static field means Coulomb's field is proportional to 1 by r square, right? Right, 1 by r square. And magnetostatic magnetic field, M.Tech theory, is 1 by r square, right? So what will be the E square, 1 by r square? Limit. So I am writing here so that it is visible from your side. P equal to this part, mu naught, 1 by mu naught, limit r tends to infinity, E dot E cross B into r square sin theta d theta d phi. Is it okay? Now in static case, static case, the electric field, that is 1 by r square, right? It is for Coulomb's law, static field. In magnetostatics, M.Tech theory, M.Tech law. Is it okay? So that means E cross B equal how much? Proportional to E cross B is proportional to 1 by r to the power 4. I can put as a constant r to the power 4. Is it okay? I am taking magnitude only. Limit mu naught limit r tends to infinity, r tends to, this is k r to the power 4, right? All other constant are in magnitude vector form I am not writing. This is what r square is there and constant are sin theta, d theta, d phi. Is it okay? Now r square cancel. So there will be r square term will remain same. Okay. 1 by mu naught limit r tends to infinity, limit k by r square. This is sin theta, d theta, d phi. This is constant. Okay. What does it means? That when r tends to infinity, so power tends to equal to how much? 0. Put r equal to infinity. Something divided by infinity. Infinity means it is very high. K divided by very high number r. Then it will be 0. That is why static charge never radiated. Okay. But in moving charge, time dependent electric field, Jacob-Minkowski equation. Okay. Jacob-Minkowski equation tells that time variation, time dependent electric field is proportional to 1 by r and magnetic field is also 1 by r. So E cross B equal to proportional to 1 by r square. Then this r square, this will become as a, so in this case 1 by mu naught limit r tends to infinity equal to k by r square, and r square sin theta, d theta, d phi, r square cancel, so it is a constant. Constant means the radiation of accelerating charge or time dependent accelerating charge produces time dependent electric field and magnetic field, and that electric magnetic field has the power, is a constant value, is not equal to 0. That's why static charge never radiated. In time dependent charge, that means moving charge, accelerating charge can radiate. And this radiation or electromagnetic wave we are discussing here, and this is the source how electromagnetic wave is generated. Okay, thank you. In the next class we will discuss the numerical problem related to the Poynting vector. Thank you.